Hi friends, welcome to this very summarized video about what an IP address is. An IP address is a unique logical number that is assigned to every device on the network so that it can be identified and they can communicate with other devices. That is an IP address. The key things to note out is it's a logical address and it is a unique number, meaning each device must receive a unique IP address for it to successfully communicate on the network. Now, the key important thing to note is that it is logical, it's not physical, because with the IP address, which is the internet protocol, this address is logically assigned to different devices. That means that it can change. Unlike the MAC address is physical in nature. Why? Because it comes burnt into the hardware. For example, the network interface card will come with its own MAC address. So this distinction matters because IP addresses can be reassigned, reconfigured, and subnetted like you'll see later on. So I want you to think of it like the MAC address, like your name. It's not going to change once they give birth to you. You're going to have your name. But the IP address, which now the network uses when someone sends data onto maybe the network and they want to locate you, they will use the IP address to locate where actually you are. So think of it like your area where you live, your address where you live. Maybe you stay in hostel, maybe you stay at MOBs. So that can change depending on where you are at that particular time. The same also applies to IP addresses. They can also change depending on the location, depending on the network where that computer is connected to. That's what we mean by that. So this is the structure of an IP version 4. Basically, it is 32 bits in length. By 32 bits in length, we mean it has a total of 32 bits, and these 32 bits are broken down into 4 octets. And these 4 octets, like you can see, 192.168.10.1, these are the different octets. The first octet, second octet, third octet, fourth octets, and they can be dotted decimal notation with a period separating the octets, like you can see here. What you should get out of this slide is that each octet has a total of 8 bits, and each octet can range from a value of 0 to 255, because when you do the binary based numbering and you do 2 to the power 6, you get up a total of 256 values from 0 all the way up to 255. So when you add 8 plus 8, 16 plus 8, 24 plus 8, you get a total of 32 bits in length. So an IP address can either be written in binary or it can be written in decimal, like you can see up there. So we can convert this binary to 255, and you can see that scale, and that is where you are able to do all those things. Now, because the IP addresses sometimes it is not enough, and we have seen that IP version 4 uses a total of 32 bits. This gives us a total of 2 to the power 32 possible addresses. When you compute that, you'll get about 4.3 billion. That sounds like a lot, but remember, we have said that any device connected to the network, any device connected to the internet must have a unique IP addresses. And we have over 4.3 billion devices on Earth at the moment which are connected to the internet, and this number is growing, so we definitely run out of those IP addresses. That's where the concept of IP version 6 comes into play. Why? Because it was created to solve this problem. Unlike this one, which has 32 bits in length, IP version 6 now has a total of 128 bits, which gives us a total of about 2 to the power 128 possible addresses, giving us about 340 udecillion addresses, which we'll probably use for some generations to come. So here we have 4 octets. Here they are grouped 8 groups separated by a colon or hexadecimal colon. Here we use the period or full stop to separate them. This is an example of how it looks like IP version 4. This is an example of IP version 6. The total devices we can get about 4.3 billion devices, and here we can get all that total. At the moment, we are still using IP version 4. It's what we're using in most organizations. They're still relying. Even the internet itself, the big part of the internet is still relying on IP version 4. However, for the future, IP version 6 is here, and it's important for you to learn and understand IP version 6, that it exists, and you'll be looking at it later. Now let's discuss just a few things about IP address classes. So when IP version 4 was designed, addresses were divided into classes based on the value of the first octet. This is called classful addressing. So we have classful addressing where we categorize, we group our IP addresses basing on the first octet. So for class A, the first octet usually ranges from 1 to 126, and the default subnet mask is usually 255.0.0.0. Why? Because for class A, allow me to just write here on the screen, because for class A, we have our network bits and we have our host bits. For class A, we have a total of 8 bits and 24 host bits. So we have a total of 8 network bits and 24 host bits. That's why we arrive at this default subnet mask. This is the private range of these IP addresses. The first bit ranges from 10 all the way up to this. It is a very large network. It can accommodate many devices simply because it has many addresses available. All right. So for us to understand, I will come back to that later, but we have another class which is class B, and the class B here, for it ranges from 128, the first octet, to 191, and the default subnet mask is 255.255.0.0. When we have our network and host, for them they share. The network bits and the host bits are sharing. They have the same value. When we go to class C here ranges from 192 to 223. The default subnet mask for class C is 255.255.255. Why? Because it has a total of 24 network bits and a total of 8 host bits. Now it's important for you to remember these things. Why? Because these things will always lead and help you when you are doing subnetting. There are other classes, we talked about them, like class D, starts from 2 to 4, and this was reserved basically for multicast, and it's usually one device sending data to a group of devices simultaneously, the one that is used in telephone masts and so on and so forth. And then class E, it was reserved for experimental purposes and research. It ranges from about 240 to 255, and I will not spend a lot of time on it. But what I want you to understand is that on every class that we have, we can be able to determine the total number of hosts, the total number of host addresses, and we do that by using our formula of 2 to power n, where n represents the number of host bits. That's why I said it's important for you to remember this table where class A has a total of 8 network bits and 24 host bits. So if you want to know how many hosts are available on this particular network, that means our formula here will be 2 to power 24, and we shall get a total of about 16,000,000.7 something addresses. And then for class B still we use the same thing, 2 to power what? N. How many host bits do we have here? They are 16, so meaning we shall have 2 to power 16, and if we are using a network of class B, we shall have a total of 65,534. That's what we shall have. And when you come to class C, we use the same formula, 2 to power n. N in this case, how many host bits do we have? We have 8. So 2 to power 8, we shall get a total of 256 addresses on this network. So basically, that is a very important aspect for you. But as network engineers, it is important for you to understand and remember these network ranges for all the classes, for class A, class B, and class C, especially if you're going to do classful addressing, as we shall discuss later on. Now, another important thing that we need to talk about is something we call the subnet mask. What is the subnet mask? The subnet mask is what tells a device which part of the IP is a network portion and which part is the host portion. Remember, when we are talking about an IP address, we said an IP address has two portions. One portion that belongs to the network and the other portion which belongs to the host. And it is a subnet mask. It is that number that helps us to denote, that number that helps us to describe which part of that IP address sincerely belongs to the network and which part of those bits of that IP address belong to the host portion. And it is also written as a series of continuous bits, just like the way we write our IP address. For example, we have this subnet mask. It is written here. We have 255.255.255, and the /24 is the classless interdomain routing notation, or the CIDR notation, or sometimes we call it the prefix. And this prefix helps us to understand and know the number of network bits. So if you ever find any IP address like 8.8.8.8 with a prefix of, let's say, 16, then this shows that this particular IP address has a total of 16 network bits. So we are talking about our subnet mask. So it can be written this way. And with our subnet mask, what you should always remember, on the subnet mask, the network bits, please remember that the network bits are always represented by ones, and the host bits, they are always represented by zeros. All right, that's what you should remember. So here, when you look at this particular subnet mask written here, we have the bits which are written in 1 and the bits which are written in zeros. This is binary. We are looking at ones and zeros. So we shall see here that our network portion of this particular subnet mask has a total of 24 network bits. We can even count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 16. Plus 1, 2, 3, 4, 5, 6, 7, 8. So when you add 8 plus 16, you get a total of 24 bits. And then we have only 8 zeros. That means we have 8 host bits. You should remember, host bits, we are looking at zeros. Network bits, we are using ones. That should always be at the back of your fingertips. So this, when you see the /24 sometimes, or when you just see this written like this, these almost all mean the same thing. The 24 is called the CIDR notation, and it just counts the number of network bits in our mask. We have given you an example here. For example, this new subnet mask we are seeing here has a total of 26. You can see the initial were 24. Now we have a total of 26 bits, and this is we can write it like this, the way it is written like this, or we can go ahead and write it as /26. That is also one way of writing the subnet mask. So it is important for you to remember that, because it will help you as you are looking at some of those different things. Now, sometimes when you are given an address plan, they may ask you for different addresses. For example, the network address, the broadcast address, and the host range. The host range means the host addresses you can assign to hosts on our network. The network address, basically, is that address that identifies the subnet itself. Let me say it again. The network address is that address that identifies the network itself, like you hear the word network address. And because it is used to identify the network, it is never assigned to any device on the network. You should always remember it. And for you to know this, you can get any IP address, and then that IP address, the subnet part remains the same, and then all the host portion is changed and is represented by 0. An IP address, for example, like this one. If they have given us this IP address, this is a network address, and this can be a network address for 192.168.10. let's say 100. Now, when you look at this IP address, you first ask yourself, which class does this particular IP address belong to? It belongs to, you got it correct, class C. And if it belongs to class C, it means the network bits are how many? The network bits are 24. And the host bits are how many? They are 8. Now, if we have 24 network bits, that means the whole of this is going to be the subnet. The whole of this is going to be the network. The first 3 octets are going to be the subnets, and they won't change. But because we said when the network address, all the host bits here, the ones you're seeing, these 8 host bits, they're going to be turned to 0. That's why this is our network address. So all the host bits will automatically be 0. And remember, this is not assigned to any device on the network. Sometimes we can ask you to identify the first usable hosts or the first usable valid address. Now, the first valid address is that address after our network address. So we shall just get our network address and we add 1. First address you can assign to the device. That is the first usable host. The last usable host is the last address you can assign to devices. And this one we can just get the broadcast and then we assign to it. Now, what is a broadcast? A broadcast is that address which is the last, the broadcast is that address which is the last in our subnet, the last on our network. So think of the network address as the firstborn, the broadcast address as the last born. And it is used whenever we want to send broadcast messages, or whenever to send a message to all devices on the network, we use the broadcast address. That is why we never assign it to the device. And to get our broadcast address, here in our broadcast address, usually all the host bits are 1s, like you can see here. When we are looking at the network, we said all the host bits are 0s, and with the broadcast here, all the host bits are 1s. So that's where we arrive, and that's where we get to that particular thing. So for us to get the number of hosts available, this is the formula we always use. This is the formula we use to get to usable. Sometimes replace the word usable with valid. So if we ask you for valid hosts, this is the formula you use. You get 2 to the number of host bits minus 2. The 2 we are subtracting is the network address and the broadcast address. These 2 addresses we never assign to devices on the network. This example we are having here, we have a total of 24 network bits and 8 host bits. So a total of 2 to power 8 minus 2, we shall get a total of 254 usable hosts on our network. All right. So we have these addresses. Sometimes they are classified as private versus public. For any device to connect and access the internet, they must have a public IP address. So we also have private ranges which are not routable on the internet. They're used within organizations, and these are the ranges, right? And any given good networking student should always remember these ranges at the back of their addresses. There are some special addresses like the loopback address, which is used to test the network of your own, like your pinging, for example. There are other addresses we may not discuss here, but these private addresses. They are used inside your home, inside our school, inside our office, not routable on the internet, and they did not directly access the internet per se. So the routers, for them, the routers you have, like the one I'm using here, for it to be able to access the network, the internet, it must be assigned a public IP address. And then that public IP address, whenever any of the devices connected to that access point want to access the internet, something called a network address translation is performed, and then they translate it into an IP address. So this is why thousands of devices from home using this particular private IP address can communicate and join the network without any issue. So what we can take out of this is that we have looked at an IP address. We said an IP address is a logical IPv4, logical 32-bit address assigned to every device on the network. You can always add the word unique, must be unique. And it has a total of 4 octets ranging from 0 to 255, and it has different classes. We have class A, class B, class C, with each of these classes having a default subnet mask. All right. So we have network address, and the network address, we said it is a first address in the subnet, and it is used to identify the network itself, and all the host bits usually are zeros, and we can't give this network to any device. The broadcast address in the subnet, all hosts are 1, and it's a last address in our network. We also never give it out to the devices. For us to find the number of hosts, we use the formula of 2 to power n. For us to find the number of valid hosts, we use 2 to power n minus 2. And basically, that is what we have been discussing. So we shall discuss later in our coming videos how do we subnet using fixed length subnetting, and also how do we subnet later on using the variable length subnetting. So thank you so much for listening to me, and see you in the next video.